Hi, welcome back to yet another section in the series Learning ECMAScript 2017, and we are going to look at the shared memory and atomics feature in this section. This section will introduce some interesting concepts on parallelism in JavaScript, which will be the first video in this section. In the second video, we will be looking at the shared array buffer, and later in the section, we will be jumping on to the atomics feature in ECMAScript 2017. Parallelism in JavaScript. In this video, we are going to look at parallelism in JavaScript and see how different it is from concurrency. We will also explore the different modes of parallelism and then quickly jump onto the history of parallelism. Shared memory and atomics in ECMAScript 2017. This was a feature that was designed by an TC39 committee member by name Lars Hansen. This feature set introduces the shared array buffer and atomics in ECMAScript 2017, which also brings in the concept of shared memory to ECMAScript 2017. More details about this feature can be found at the ECMAScript shared memory page at the TC39 GitHub page, which is shown in this slide. Before we jump onto the shared array buffer, it's important to know these two terms better. One is the parallelism and the other is the concurrency. In simple terms, parallelism is the opposite of serial, which means you execute multiple things or multiple tasks simultaneously. On the other hand, concurrency, which is a kind of opposite to sequential, refers to executing several tasks or several things during the overlapping time period. This means that the task is not run one after another. This brings us to the next question on what other modes or models of parallelism that exist. It can be classified into two simple modes. First one is the data parallelism, which refers to the same piece of code that is executed several times in parallel. The second one is the task parallelism, which refers to the examples like web workers where different pieces of code are executed in parallel. When it comes to the history of parallelism, it all started with a single-threaded application. The JavaScript was initially started to be executed in a single thread, and later the concept of asynchronous programming was brought into it, where the tasks were run in separate threads and later used the callbacks. Then came in the web workers, which had actually brought the task parallelism to JavaScript. Web workers was considered to be a kind of heavyweight process wherein every worker had its own global environment and nothing was shared. Then we had the introduction of WebGL, which worked like a hack, wherein the data that was input was converted into an image and later the OpenGL pixel shaders could be used for computation on the GPUs. After this, we had the low-level data parallelism, which was supported via simd.js, which allowed to perform operations on several inputs at the same time. Let's have a quick look at the web workers demo. For this demo, we will be using Visual Studio Code, the IDE or the editor, to get our ECMAScript code running, like the way we did in our previous demos. In this example, we have index.html page, which is a UI that contains a text box. Additionally, it also contains hello.js file, where we have created an instance of the worker by specifying the worker.js JavaScript file. With the help of the onChange event of the text box, we try to post a message to the worker, say in this case it's hi, and display a message into the console saying the message being posted to the worker. And on the message, we also display a message that is being received on the console. The worker.js file contains the onMessage function or event which gets triggered, and in this case the calls to the post message to return a string back which is received by the worker's onMessage event of the worker. When you run this in the browser and open the console window, you should see the flow in action which displays the message in the console window. To run this particular application on the web server, we use the command http server in the npm. And when your web server is being started, you just open the page in the browser and type in some data in the text box. Immediately, you should see a message being displayed in the console stating message posted to worker, and it also displays hi and ho, which was been the message that was displayed in the hello.js file. In this video, we looked at the introduction to parallelism in JavaScript, and we also covered the web workers.